is on waves in motion. So if you recall from last time, we talked about vibrations and harmonic motion. So we did stuff like where we took a weight and we hung it from a spring, and then we pulled it down and we let it go, and it vibrated up and down. So that was motion in time. Now in today's lesson we want to talk about motion in space. So think about what an ocean wave does. The ocean wave is traveling sideways, so it's traveling through space. So that's the kind of phenomenon that we want to talk about today. So our lesson objectives are: explain the difference between mechanical and electromagnetic waves and give an example of each kind. Explain the difference between a longitudinal, a transverse, and a surface wave and give an example of each of those. Explain what a traveling wave and a standing wave looks like. Number 2, explain what frequency corresponds to in sound and in light waves. Explain what amplitude corresponds to in sound and light waves, and explain what the wavelength of a wave is. Number 3, explain how a mechanical wave travels through a solid or a fluid. Given the speed of a wave, calculate its wavelength if its frequency is known, or vice versa. Calculate how the intensity of a wave varies as a function of distance. Explain what the decibel is. Know the definition of absorption, refraction, reflection, and diffraction. Know what the Doppler effect is and what causes a shock wave. So in your textbook, Conceptual Physics by Paul Hewitt, be reading chapter 19, sections 3 through 8. And then there is some videos available. So there's crash course physics videos available, and there's also physics fundamentals videos available, and then there's also physics in motion videos available. All right, let's take a break, and when we come back, we will talk about different kinds of waves.